Hi my friend, welcome to Joystick. I am Joey, and in this video of Joystick we are going to solve the problem of longest subsequence with adjacent difference as 1, which also happens to be one of the variations of the classic longest increasing subsequence problem. We'll be solving it using dynamic programming, and we are going to see the problem statement of it in the next slide. So we are given a series of integers, all right, and this is our series of integers 5, 9, 6, 11, 7 to 8. We need to find the longest subsequence of integers. Okay, just keep in mind not the substring but the subsequence. Okay, it doesn't have to be contiguous. So the longest subsequence of integers that we need to find has a condition, and the condition is that the entire subsequence, okay, must have the difference of integers as 1. All right, that means any two contiguous integer I pick from that subsequence must give me the difference as 1. It will be very clear when we see the solution of this series of integers, the longest subsequence of integers, which is going to give us the difference as 1. So the solution is 5, 6, 7, 8. As you can see, the difference between any two integers here is 1. So difference between 5 to 6 is 1, 6 to 7 is 1, and 7 to 8 is 1. Now we'll move to our framework and we'll solve this problem. But before we move there, a humble request again to hit the subscribe button just now if you're new to my channel, and hit the bell icon as well, because that way you will get notified whenever I release new videos like this. Okay, and any doubt you have regarding this video, just put that in the comment section and I promise you that I'll solve it within 24 hours. So let's move to the framework and solve this problem. Now this is our framework. This is our series of integers, an array, and this is a solution array which we are going to fill to get the longest subsequence with all integers which have the difference as 1. The adjacent integers of that solution subsequence is going to have the difference as 1. So the base state is always going to be 1. Okay, if you are wondering why I am putting 1 over here, then you can check out my longest increasing subsequence video, the link to which you can find here above as well as in the description of this column. In that video I have explained the longest increasing subsequence problem and the reason why I have put 1 in the base state. All right, so we are going to start from here. We have put the j counter here and the I counter here. Okay, so we just have to check our condition that the difference has to be 1 between the two integers we are checking. So what is at j? We have 5 at j and we have 9 at I. So what is the difference between 9 and 5? It is 4. So it violates our condition. That means nothing gets done over here. All right, we move I one cell to the right. Okay, now let's check the difference between j and I. So it comes out as 1 now, as you can see. So what is the value here? 1 plus 1, because we have got one more integer. So it gives us 2. Now is 2 greater than this one? Yes. So I am going to replace this one with 2 and I will move j to the right. Cool. Now let's again compare the values of j and I. So j has 9 and I has 6. So what is the difference I'm going to get? 3. Now I'll have to consider the absolute difference, so please do not consider the negative sign. Okay, the difference is going to come out as 3, which violates our condition, and hence we are not going to consider this iteration. So j goes back. Okay, and I moves 1 cell to the right. All right, again we compare the values of j and I for our condition. So the value at j is 5 and the value at I is 11. The difference comes out as 6. So this iteration won't be considered. J moves one cell to the right. Now what is the value over here? The difference between 9 and 11 is 2, so that violates our condition again. Nothing happens. Okay, J moves here. What is the difference between 6 and 11? It's 5. It again violates our condition, so nothing happens. J moves back to its space position and I moves one cell to the right. Alright, now we compare the values of J and I again. So J has 5 and I has 7. 7 minus 5 is 2. Nothing happens. Alright, because it violates our condition. Then J moves here. Again 9 and 7. So the difference is 2. Nothing happens. J moves one cell to the right. Now here the difference between 6 and 7 is 1. Alright, so that satisfies our condition. So what we are going to do? We are going to add 1 because we have got 7 to this value over here. So that is going to give me 3. Now is 3 greater than this one? Yes, it is greater than this one. So we replace this one by 3. Cool. Alright, we move J over here and as you can see the difference between 11 and 7 is 4, so nothing happens again. This iteration will not be taken into consideration. So J moves back to its space position and I moves one cell to the right. Okay, so 5 minus 2 is going to give me 3. Okay, that doesn't satisfy our condition, so nothing happens. Over here it's 9 and 2 again. The difference is not 1, so nothing happens. Let's move J to the right. The difference between 6 and 2 is 4. Nothing happens again. It has to be 1. We come here, so difference between 11 and 2 is 9. Nothing happens. J moves one cell to the right. The difference between 7 and 2 is 5. It is also not equal to 1, so nothing happens. J moves back to its base position. I moves one cell to the right. Alright, now we have J and we have I. So the value at J is 5, the value at I is 8. So 8 minus 5 is 3. So 3 is not equal to 1, so nothing happens. We move J to the right. So it's going to be 9 minus 8. Now over here, okay, the difference is 1. So what we are going to do? We are going to add 1 to this one and we will get 2. So is this 2 greater than this one? Yes, it is greater than this one. So I'm going to supplement. I'm going to substitute this value with 2. J moves one cell to the right. So what is the difference between 6 and 8? It's 2. So nothing is gonna happen. Here J moves one cell to the right. So it's 11 and 8. The difference is 3. It doesn't satisfy our condition. 3 is not equal to 1, so nothing happens. J moves one cell to the right. Okay, now the difference is 1. 7 minus 8 or 8 minus 7, whichever way you want to take it. So what we are going to do? So we are going to add 1 to this 3. So it's going to give me 4. Now this 4 is greater than this 2. So I'm going to substitute this 2 with 4. Alright. Now J moves one cell to the right. As you can see, 8 minus 2 is 6. So nothing happens. J moves back to its space position and here we have filled the array. So we are going to traverse this array to find out the largest integer. That comes out to be 4 over here, and that is our answer. So in our problem statement slides, in one of our problem statement slides, we saw this longest subsequence with adjacent integers. So in one of our problem statement slides, we saw the longest subsequence with the difference between adjacent integers as 1, as 5, 6, 7, 8. The length was 4 and it is 4 over here. In the video which I have made on longest increasing subsequence, you will find a way to determine the exact subsequence, so you can learn from there. Okay, it is very easy. Any doubts you have regarding this video, you can put that down in the comment section. Now let's check out the algorithm of this dynamic programming solution. So here we have the algorithm. If mi is less than 1 plus mj and pi minus pj is equal to 1, then mi is going to be 1 plus mj, else mi is going to stay as mi. With this, we have come to the end of this video. I hope that you liked this video. If you liked this video, then do give it a thumbs up. I look forward to help you with algorithms and programming. Hasta la vista. Goodbye.